we have a tall person. So we're given that she happens to have a height of 172 centimeters. So we have a person lying on a bench like this, with the legs flat, and on the two sides of the bench we have weights. So these weights show the measurement. So this one is recording, the left weight is recording 35.1 kilograms, and then the right weight is recording 31.6 kilogram. And those are the masses. The bench is massless. So this bench right here is massless. And also these are scales. So this is a scale that measures the weight. Assuming the weight of the head is pushing down and the weight of the legs is also pushing down. And the distance between them, as we've said, is the height, which is 1.272 meters. If you change centimeters to meters, you have to multiply that by 1 meter of 100 centimeters, and that gives you 1.72 meters. And so we also have the center of gravity. Okay, we have the center of gravity, and our goal in this project is to determine the distance between the center of gravity, from the center of gravity up until her feet. So we're going to call that X. So that's the goal of the project. We'll take these two forces. So this is pointing downwards, 35.1 kilograms. That's the scale right there. And this one also is 31.6 kilograms. And we want to see what's this distance X. That's our target. So the sum of forces, or rather the sum of the torques on the center of gravity, and this is the whole center of gravity of the whole system. So assuming this is the center, so we'll call it CG. So the torque relative to the center of gravity is 0. And so we're going to take this weight. If we're moving clockwise, if the force is moving clockwise like that, that's going to be negative. And if it's moving counterclockwise, this one is counterclockwise, this is positive. So we'll start with the counterclockwise one, 35.1 kilograms times the distance X. Okay, times the distance X. We want to find this distance right here. So there are two distances. This distance right here, you can see it's going to be the whole entire length, meters, minus X. So this will be times 1.72 minus X meters. This is positive because it's counterclockwise, and then the clockwise one is the scale on the leg, so 31.6 kilograms times X. Our goal is to find X, so you make that equal to 0. And so we end up having, we use distributive property. So this one and that one, we have 35.1 kilograms times 1.72 meters, and then minus 35.1 kilograms times x, and then minus 31.6 kilograms times x, like that. That's equivalent to 0. And we're going to go to the next page. So in the next page, we get to see that simplifying the problem, we just have to go back and check. So simplifying the problem, we get to see that 35.1 times 1.72 is going to be equivalent to, we have to do the math in that one. So 35.1 times 1.72, 60.372. So 60.372 kilogram, we could say kilogram meters, minus, going back, 35 and 31, 66.7, minus 66.7 x, minus 66.7 x. That's going to be equivalent to 0. So then this is in kilograms, because we only have that one for kilograms. So then we get to see that 66.7x becomes equivalent to 60.372 kilograms meters. And then we have to divide both sides by 66.7 kilograms. And so simplifying that, our x becomes equivalent to 0.905 meters. So hope you enjoyed the problem. Feel free to send any questions and comments. Here we're using torque to determine the distance from the leg of the tall person up until the center of gravity. We're calling that x. So all our torques are relative to the center of gravity. So the first one would be this torque due to the left force, or the left mass, 35.1 kilograms, and we use that right here. And then the distance is the entire 1.72 minus this x, minus the x, and that's what we have right there. And then the other torque is due to the mass on the leg, so 31.6 kilograms times x. And then we simplify that problem, we get 0.905 meters. So hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks, bye.